MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier application for inverting and non-inverting amplification. The aim of the experiment is to construct and test the performance of an inverting amplifier using IC mu A741 and to construct and test the performance of a non-inverting amplifier using IC mu A741. The design formulas and calculations for choosing the components for the experiment is shown here. Gain value will be chosen by the designer for the operation. Here, the gain value chosen is -5 for inverting op-amp and 6 for non-inverting op-amp. Assume any resistor value to design the other values in the circuit. The figure shows the circuit diagram of inverting op-amp and the output waveform. The output of inverting op-amp is out of phase with 180 degree that will be plotted in the figure. The input for the circuit is given to the inverting terminal and the non-inverting terminal is grounded. Let us start the circuit connection based on the circuit diagram. The figure shows the circuit diagram of non-inverting op-amp and the output waveform. The output of non-inverting op-amp is in phase that will be plotted in the figure. The input for the circuit is given to the non-inverting terminal and the inverting terminal is grounded. Let us start the circuit connection based on the circuit diagram. The result of inverting and non-inverting op-amp is noted here in terms of volts.
Dear students, today I am going to explain the operational amplifier applications for inverting and non-inverting. The aim of the experiment is to generate the waveforms for inverting and non-inverting applications by using a IC mu A741. Now the components required for the experiment is signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, herb wave and noises that will be used to generate the signal to the input for the circuit. DC regulated power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Digital oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as a channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Mu A741 IC This is IC MUA741. This IC contains 8 pin. Okay, that will be start with the pin number of this notch. This is the notch that will be indicates the pin number 1. Okay, this is pin number 1, 2, 3, 4, 5, 6, 7, 8. This is the 8 pin IC MUA741. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is a series connection. So this is a series connection in x-axis, and this is a series connection in y-axis. Till this division that will be counted to 5, till that it is a series connection. After that this is one connection. Resistors. In this experiment I am going to use 833 ohm resistor, 1 kilo ohm resistors and 5 kilo ohm resistor. Patch cards. This is the patch cards that will be used to connect the input and output devices to the circuit. Connecting wires. These are all the connecting wires to connect the circuit. Now let us start the circuit connection for inverting amplifier. Now let us take the circuit board for the connection and take the MUA741 IC. So this IC is an 8 pin IC. So we have a notch here. So from this side we count the numbers. This is the first terminal, second terminal, third terminal, fourth terminal, fifth, sixth, seventh and eighth terminal. Now I am going to mount this IC to the circuit board like this. Mounted the circuit board with the IC. Now I am going to place the resistor values. Based upon the design we choose this resistor values. This is the resistor value 833 ohm that will be connected to the terminal number 3 to ground. You see the terminal number 3 is here, 1, 2, 3, 3 to ground. I made this as a ground. Next I am going to connect 1 kilo ohm to terminal number 2. Terminal number 2 is here. I connected this 1 kilo ohm to here, and somewhere the point I created in the circuit board I connected to here. Now the resistor 5 kilo ohm that will be connected to the terminal number 6 to the terminal number 2. Now I am connecting this to, you see, the terminal number 6 and the terminal number 2. So now it is connected to terminal number 2 and terminal number 6. Take two connecting wires to connect the positive and negative terminals of the supply to the circuit board. This positive end of the supply that will be given to the pin number 7. Where is 7? You just see 5, 6 and this is 7. I connect this pin to here or here. Now it will be connected to pin number 7. This is 6. Now you take the negative one, negative supply voltage, that will be connected to the pin number 4. So you see the pin number 4 is here. The pin number 4 is here. I am connecting that into pin number 4. After connecting the DC regulated dual power supply to the circuit board, so we must connect the input. So the input is given by the signal generator. So that will be connected by using the probe. So to any one of these terminal, I'm going to connect this with this terminal. The positive and negative terminals I need to connect. The positive end I'm going to connect by using the connecting wires like this to the terminal number 2, but the terminal number 2 that will be connected with the 1 kilo ohm resistor. Now my input is here. Okay, I need to connect this input positive to this terminal, this series line. So now it is connected with a pin number 2 virtually with this resistor. Okay, the negative supply connect to ground. Okay, so this is the ground. I made the point here, the ground. I connected this into ground. The input connection is over. Now I want to see the output by using the digital oscilloscope. Now I am going to take two probes. One probe is for input connection and another probe is for output connection. So I am going to connect to see the output first. I can use any of these two channels. So I connect this probe to this particular channel to see my output. So the output that always exhibit in a pin number 6, I take the connecting wire and I connect the positive terminal to the pin number 6. You see 5 and 6 is this pin number. This is the 6th pin. I'm going to connect this to here. This is the 6th pin I connected. Now I am going to connect the negative terminal to the ground like this. The negative terminal I connected to the ground. I made the ground in this point. I connected to here. It will be connected to the ground. Now I am going to see my input the same way. I connect the probe to another terminal of the digital oscilloscope. So next I take the positive terminal of the probe is connected by using a connecting wire with the terminal number 2 because I am given an input here. This wire is taken input. In the same way I connect this into this particular series line. Now it creates an input. Now I am going to take the negative end of the probe. I will connect it to ground. Okay, I made the ground somewhere here. So I connect this into here. Now the connection is completed. Now you can see the output. So now you switch on the signal generator and you switch on the DC regulated power supply. Before switch on the DC regulated power supply, your voltage must be in minimum position. Okay, now you switch on the power supply and you switch on your output monitor oscilloscope. And you put the voltage to 12 volt because it's a saturation voltage that will be given to the IC MU741. Based upon the data sheet we are given this. Volt. Now you switch on your input using this point. This shows the output for inverting amplifier. Say our input waveforms that will be started with the negative, our output waveforms that will be started with a positive. So you can stop the signal. So if you want more clear, you can switch. So it will show us 2 two different phases of the signal, our operational amplifier works as a inverting amplifier. Now we complete the inverting amplifier waveform generation. Now we can see the non-inverting amplifier waveform generation. I'm going to show the non-inverting amplifier circuit connection. So small corrections that will be happen with the circuit. See here, I'm going to remove the input terminal first. Okay, I remove the input terminal from this point and this point. Okay, so I'm using this wire to see the input waveform. To see the input waveform, I use this wire. I'm going to remove the connection of this. So I remove the connection of the positive and I remove the connection of negative. Okay, my output that will be seen by pin number 6, that will be the same, that will be connected to ground negative terminal. Now you connect this 833 kilo ohm to somewhere here, because this that will be connected with the terminal number 3, it's a non-inverting terminal. Now I'm going to remove this, okay, by using this hand. I'm going to remove it and I keep this to somewhere here. Okay, this point I'm going to connect that 833 kilo ohm. Now the 833 kilo ohm that will be connected somewhere in the circuit board to the terminal number 3. The same way I'm going to connect the input to the circuit. So positive end I'm going to connect to the 833 kilo ohm that will be connected with series to this line. So I connect this connecting wire to here. I place the input. The negative end that will be connected to the ground. In the same way, I am taking the CRO probe to see the input. I am connecting this input positive to here, somewhere in this line that will be connected with 833 kilo ohm. Now I connected the input to the same series line 833 kilo ohm to here, and the negative I am going to connect to the ground. This is my ground point. I am going to connect it to this point. We can see the output of non-inverting amplifier. Now we can conclude our operational amplifier MU741 works to generate the non-inverting waveforms. This completes the experiment of inverting and non-inverting applications of operational amplifier.
At MSR UAS, we spark your imagination unlike any other.